operators, and we have seen how we can create a superclass and subclasses that will inherit from the superclass. We demonstrated with an examples. I think we gave one example using bank accounts class that we have created earlier. So we enhanced that program by extending to have subclasses. We started with bank accounts in order to demonstrate the general concept of object-oriented. But then as we come to start the inheritance, we extended that class, bank account, where we created sub classes. We created savings accounts, where I asked you to go and add more functionalities to create current account or any other maybe sub account as the case may be. So you can have as many as possible, as long as it's going to be an extension from the base class. So you see how flexibility it is. When you structure your program, you can always extend from an existing code. This is one of the good features of inheritance. So you don't have to invent or code what you have coded earlier. So you can just look at possibility of extending from an existing class. So if you can still see my screen, I think we can brush over what we did last, and then we start abstract classes and interfaces, probably polymorphisms all today. So remember, when we created a superclass and subclasses, we use extend keywords to indicate which class is the super, which one is the subclass. So we use the extend keyword to clearly indicate that, which from the code we have written last week. We have seen the use of these extends. Now we talk about object class, which we said is the ultimate superclass of any classes that is not explicitly said to be a subclass of any class. And I remember when I asked someone, I said, what is a superclass of bank account? Someone said object, because if we have not specified that bank account is a subclass of any class, then it's a subclass of object. However, remember when we wrote that program last week, the bank account class, sorry, the savings account, which is a subclass of bank account. So if you now ask, what is the superclass of savings account? We cannot say object. It is bank account. That is a superclass of savings account, because there is one child will only have one parent. And no class without parent. Any class without parent is a child of object class. Then we have seen the overriding methods, which I demonstrated with the withdraw method and deposit method, where we've seen that some little modification needs to be achieved in the subclass. Remember where we said the savings, or the savings account, we have a different implementation of the method. Therefore, we need to override the method of the superclass. That will state the condition. Looking at the two classes have different distinct way of implementation, or the real functionality of how the method should be implemented. So I think probably we're going to give one more example in order to understand better. But I think I demonstrated with this overriding. Remember, the overloading method is just an ability to have more than two methods in the same class, but with different signature. The overloading must be different signature, but in the overriding, they must have the same signature, because the overriding occurs when we have superclass and a subclass. But the overloading is just within the class. To have two or more methods, but with different signature. Signature means number of parameters or type of parameters. Then what can be actually inherited? I think we have discussed about this, where we say a private member cannot be inherited, but anything public can be inherited. How can we inherit, or can we get or can we access a private member of a superclass or of a class? We get it, or we access it through a data method, if you remember. It's called this. There is single versus multiple inheritance. Of course, Java supports only single inheritance. It doesn't support multiple inheritance. Then the upcasting, where we change the type from the superclass, sorry, from a type of the subclass to a type of the superclass is called upcasting. We also later going to see the downcasting, which we have seen that in 211. However, we're still going to demonstrate to give more examples. So remember, we have discussed, or this is just a brush up of what we did last week. Here is a super class, and here is a subclass as a graduate student extend from the student class. So the subclass of this student class is graduate student, and the superclass of graduate student is student, and the superclass of student is object, because there is no any class that is a superclass of student as specified in the class hierarchy here. Therefore, it is a subclass of object. So this is an example. This is another example apart from the one we have seen for the bank account. So this is an example here written in your slide. We use the extend keyword as I mentioned here, and look at it. Graduate student extend student, meaning that this graduate student is a child of student class, meaning it's an extension or it's derived from student class. So all the public members here can be inherited by a graduate student, while the rest cannot be inherited, like name, ID, and GPA cannot be accessed outside this student class because they are private. It's just like, remember when I give an example of saying that, okay, you have a car and you declare that car as a private, meaning no one can access the car unless you, or you can decide to extend the scope within which the car can be used. You can say the car can only be used within your family. So if the car is can only be used within the family, then that is a private to your family. Anybody who is not belong to the family cannot use the car that is private. But if it is public, we say public, meaning that it can be used by anyone. But that's, of course, you know, if you say it's going to be used by anyone, it means you are making it so porous that it cannot guarantee, the security cannot be guaranteed. But this is one of the good things, what you call encapsulation Java provides in order to hide some things like not relevant, in order to make sure that security is enforced. So the graduate students, which is a subclass of students, what indicate this graduate student is a subclass of students is because of the extend keyword. This extend keyword showing that graduate student is a subclass of student, meaning it's derived from student. Therefore, whatever we have written here, we don't need to repeat them in the graduate student class. Can be inherited by the graduate student. So this is good thing about this. However, remember that an additional method can be added. This is why we have added method here. We have dependencies, which is a method that is not available in the student class. But all these methods that are public, these are constructors. This is a constructor, this is another constructor, two constructors called constructor overloading. Remember, we discussed this. Then all these public members, the method here can be accessed from the graduate student because they are public. But this private member is not possible. There's no way to access such. So here we go now. I think we have discussed about the objects, which I said is in java.lang if you refer to the last two lecture, and I also discussed about the string method. And we have seen how to call the string method in two different ways, either implicit or explicit call. So the overriding methods, what do you mean by overriding? When you define a method in the superclass and you want to implement the method differently in the subclass, but of course you have to have the same signature. This is called method overriding. Yes. But one has to be in the superclass, the other one has to be in the subclass. So we refer them as method overriding. So this is method overriding. The string method here is a method overriding. Why we call it method overriding? The method defined in the student class. However, we come to the subclass, which is the graduate student, and we did that same method. Look at it, public, public, string, string. to string to string. The parameter empty, parameter empty. Therefore, this is called overriding method. Yes, overriding method, if you remember last week, where we want to return some of the details in the super class, we use the super.toString in order to call the string of the super class. If you don't write this super, it will be like a recursive call. It will be calling itself. So meaning that when it comes here, when the compiler sees this to string, it will call this rather than calling the string of the super class. That is, if this super dot is committed, then it will be calling itself, and that will now be a recursive call. Which, if there is no stopping condition, in this case there is no stopping condition, the program will now run out of memory, and your system will hang in that case. So these are the differences between the overriding and the overloading method. Remember, the overriding, like I said, you have in the superclass and you have it in the subclass. But the way the method will be implemented will be different. So it's just like the kind of a way in which a parent class wants to do certain things and the child class wants to do it in a different way. That child needs to override the method of the superclass. Like for instance, I said, my parents sleep. I, as a child of my parents, I also do sleep. Then I can decide to inherit the way my parents sleep. The same way, everything the same. I will just imitate the same thing, exactly. Therefore, if I'm going to use the same way as my parents, I don't need to define my own way of sleeping. I can just use the way my parents sleep. Simple. But if at all I have to sleep differently, then I need to override, meaning to define my own way in which I want to sleep. That is typically what you mean by overriding. So here now we said deals with two methods, one in the parent class and one in the child class with the same signature. Remember, we said with the same signature. As long as they have different signature, signature means type of parameter, order of parameters, these are signatures. When I say parameter, I believe you understand what I mean by parameter. Remember, in the withdraw method, we have amount as the parameter to the withdraw method. So that is what it refers to as parameter, the amount. And remember, we had a withdraw method in the superclass and we have it in the subclass. That is typically what we mean by method overriding. But if one is having two parameters, one is having one parameter, then it's no longer a method overriding. Meaning it is not redefining the way that methods defined in the superclass also implemented. These are two different methods entirely, and they don't mean the same thing. So the overloading methods is when we are dealing with in the same class but with different signatures, meaning we cannot have the same number of parameters or the same type of parameters. Their type matters as well. Remember last 2 weeks, did that how to match when we make a call to any class. So then what is the purpose? We said, let you define a similar operation in different ways for different object types. So the object of parent and the object of child, I want to do things differently. So this is why we may state this overriding method. But this overloading lets you define a similar operation in different ways for different data. So it depends on the data. Remember, even like say substring. Substring is a typical example of overloading method. In the substring, which is a method in object class, there are some cases where we need to pass one parameter, sometimes we need to pass two parameters. So such is called method overload, which depends on the data we have and operate on the data dealing with. So what cannot be inherited or what can be inherited? One of the things is constructor cannot be inherited. You cannot inherit constructor. You cannot inherit constructor. Even though it's public, but it's not something that can be inherited. But it is called when an object of the class is instantiated or is created. And this should be the first thing that you always want to have. Anything that precedes this, if you remember, refer to our last week lecture. I'm just doing a recap now. We have discussed all of this. where I have interchanged this, we see that that's report an error. And the same thing, when I now decide not to have a super keyword here, we say compiler will insert a call to the superclass constructor, which is calling a default constructor. And if that default constructor does not exist, then that will lead to an error. So this is typically what this point is telling us. If super is not used to call the parent constructor, the compiler inserts a call to the parent default constructor. That is a constructor without parameter. And if you have created your own constructor, the default one will not be created. That is the condition. So if default one will not be created and you allow the compiler to create the default, then if you don't have the super keywords to call the constructor, to implicitly call the constructor of the superclass, the compiler will insert that default that will correspond to the default one also. But if you define that default will not be created from the superclass. And if you don't have a super keyword in the graduate student sphere, then the compiler will automatically insert a call, which leads to error because you have already created a constructor in your own class, unless you go and add a default constructor yourself. So instead of allowing the compiler to insert, and simply because you have created one or two constructor with parameters, then of course the default one will not be created by the compiler. But if you want, you can still go and add, so that if you don't have the super keyword here, then the compiler will allow that to go, because the insert default constructor will correspond to the default one that you have manually added. Then what can be inherited, what cannot be inherited. Remember, we said any public thing can be inherited, the private things cannot be inherited. And when we talk about this, we are dealing with a memory where data value will be stored. So it means that where you have like a memory, data will be stored like 3.5 here, stored in this memory. And we said this memory is public, meaning from any class you can come and access this. You can change the value, you can read the value without any restriction. But when we make things to be private, it means only members within the class can access the private member. So this is why we say if GPA is private, it is not inherited here. So you cannot inherit this method at all if it is a private. So at what point? This is a creation of instance. That is an object of the graduate student class with the parameters. I think I've demonstrated this similar example in our last week's class. Created bank account, savings account as an example, where we differentiated, added some values there. In fact, we have even automated the way that user will supply the name and some other details so that to perform transaction, just as the way by ATM operates. So I think this is just for the private and something. I think I've discussed about the string methods, but dealing now with objects. Yeah, we have the getters, get name, get ID, get GPA, set GPA. This allows us now to access because they are public. In most cases, they are public. If they are public, all it does here, like get name, will go into the memory and get the name here, Usman, and Usman will be returned. We say get ID, will come here and get this ID and return. Get GPA, will come here and get the GPA and return. That's all. So it is a combination of this. Instead of having system.out line, get name, get ID, get GPA, set GPA, we have it all in a single string method that will return the string representation of this object. And then the private fields, which we said cannot be inherited, like the clone, equals, and the rest like. So what about the protected visibility modifier? Something in between the public. If public is allowed to be accessed from anywhere without any restriction, and private is not allowed, is there anything in between that is not as weak as public and is not as restrictive as public? So the private. Is there anything in between? Yes. The answer is yes, and that is called protector. So use a protected member. Later when we start packages, most likely by next week. When we start packages, we discuss to what extent can we assess the public, private, and protected members access notifiers. So we said, of course, for the private, we're only within the class can access, public across all. So meaning later when we discuss about packages, now see that how public is so porous, not only within class, not only within subclass, even across packages, you can access a public member. And we see, of course, there are four, which we're going to talk about them later. The defaults, public, private, protected. So again, we said Java doesn't support multiple inheritance. Of course, it doesn't support multiple inheritance. And clearly we have seen these students as a subclass of objects from the previous something. And graduate student is a subclass of student. Therefore, this graduate student cannot be a subclass of any other class apart from student. And student cannot be a subclass of any class apart from object. Now, in order to avoid this complexity of saying the grant or graduate students in subclass of this class and graduate students in subclass of another class, this will cause like more of what you call collision. In order to avoid that, Java decided not to have a multiple inheritance, but only to make it single inheritance. Okay, so this is an example. We have a staff here. A superclass of staff is employee. A superclass of faculty is employee. Okay, of course, we see that faculty and staff are siblings, all belong to the same superclass employee. An employee is a subclass of person. And a person is a subclass of object because it is not specified that it's a subclass of any class. That was a subclass of object. Coming here, student is a subclass of person, a graduate student is a subclass of person. So, and this is obvious. We know that every staff is an employee and every faculty means every lecturer is an employee and every employee is a person. Every student is a person and every graduate student is a student. So this is the way we class hierarchy. Now, dealing with upcasting. Remember, I say upcasting is changing the type of the subclass in charge of the superclass. It's called upcasting. So an object reference can refer to an object of this class or an object of any class related to it by hierarchy. Meaning, I can create like in our last week, let me open the last week and then demonstrate with that so we can move. Open the bank account. Yes, class. Am I audible? Can you all hear me?
Yes, sir. We can.
Yes, sir, you are audible.
Yes, sir, we can hear you.
Okay. See the driver class. Okay. Now looking at this, the driver class, this savings account, I'm trying to explain this point. It says an object reference can refer to an object of its class. So meaning an object reference refers to an object of its own class, like we have here savings. This reference savings account refers to a savings account class, which refers to itself. Or any class of or to an object of any class related to it by inheritance. Meaning, if I like here, I can change this to bank account. And it's still fine. I can change this to bank account and it's still fine. Why? Because savings account is an account. Savings account is a bank account. But not every savings account is a savings account, because maybe current account. So this is what we mean by inheritance and upcasting. So this is what will now lead us to what we call upcasting. Okay, but later we discuss about polymorphisms. Now, bank account here is a super class of savings account. Therefore, savings account is a bank account. So we can either use savings account here, or we can refer to it as in super class. Then we write something here so that we can. Let me create another one. So here I will now make it bank account. Now, if I use this bank account, because I know savings account is a bank account, okay, that's fine. But one thing I cannot do, I cannot say current account, because current account or savings account is not a current account. Can only be a current account if current account is a subclass of savings account. Yes. Just like we have here. If I refer back to this, we can see here that if I have anybody who is an employee, I can say that employee is an employee and that employee is a person. Just like I can come here and write something here. To say employee. Let's say imp equals to new employee. Meaning employee is an employee, and I can come here and say employee is a person. Let me see imp one is to new. And obviously you can see here that I can say anybody who is an employee, that employee is a person. So here I say employee is a person. Or employee is an employee. This is one itself. Because every employee is an employee and every employee is a person. Therefore, I can write it this way. But one thing I cannot do is to say employee, let's say imp2 equals to person. What I'm saying here is a person is an employee, which must not necessarily be, because a person can be a student. An employee is not a subclass of, it's not a superclass of person, therefore cannot be a person. Or cannot be an object here, cannot be an employee. Yes. We cannot use to reference employee. Because a person is not an employee, but an employee is a person based on this class already. So if you look at it from the bottom up, anybody who is a staff is a staff. Anybody who is a staff is an employee. Anybody who is an employee is a person. Anybody who is a graduate student is a student, and anybody who is a student is a person. So it means I can create an object of reference to reference this. I can use it to reference this. I can use it to reference this. Like for instance, I can still go back to this. Let me put it side by side. I can say staff. Let's say st1 equals to new staff. So I'm now representing staff class. Because anybody who is a staff is a staff. Okay, staff to staff. Fine. It's referencing itself. Now, I can also say a staff is an employee, therefore I can put employee there. Because anybody who's a staff is an employee, therefore I can write it this way. And anybody who's a staff is also a person. Can be this way. Anybody who is a staff is a person. Sure. Because a person is an employee. From that hierarchy, can do this. Again, I can also say this employee, as I have it over up there, is a person. I can do it this way because an employee is a person and a staff is a person. A staff is an employee. So it means staff can be represented as a staff can be represented as person, staff can be represented as employee. Later we talk about this is typically what you mean by polymorphism, nothing more. Different way of representing object. So all I'm trying to explain here is the upcasting. So if we have the upcasting, one thing you should understand, let me come here to explain the why do we need for upcasting. Let's come to the bank account class. Let's have a method that does not exist in the subclass. We have transfer in the savings account. No, we don't have transfer here in the savings account. Fine. This is a very good example. We don't have stuff here. Yes. Now, when I come to instantiate this, let me go to the driver class so I can demonstrate. So when I come here and I said this is a bank account, well, let me use the savings account. Anyway, let me come here. Let me come to the savings account. Yes, let me create the method here. Let me create one more method here. Because if it is a child class can inherit parents. So if I use the method of this, I can call transfer, and that's fine. It's possible. I can call transfer. If I use savings account here or bank account here, I can call any method that must not exist in the savings account because I can make transfer using the transfer method of the superclass bank account. But one thing I'm trying to change now is to say this savings account is of this type. I now use this object to call, or let's say bank account, yes, still bank account. But they use this AC2 to call the method of the savings account. While the AC2 belongs to, is an object of bank account. And we cannot use this AC2 to call the method of the savings account because parent cannot inherit child. Only child can inherit parents. So in that case, let me have a method here, public void, let's say call me. Just have a method say call me. System dot out dot print line. Let's say checking method call. Okay, so let's say checking method call. And now go back to this. I want to use this AC2. By inheritance, we remember this, we said a reference of this can be used to refer to the savings account, or reference of this can be used to refer to itself and any class above it in the class array. So it can be used for the bank account. Therefore, let me come down here and say AC, let me make it AC3 because you cannot have duplicate variable. AC3 dot call me. Now I'm calling the method. So this is the call that we said it's not possible. The compiler will throw an error, cannot find method call me because there is no call me method in the bank account class. It's only available in the savings account, and this is not referred to the savings account unless if I change this to savings account. That's fine. I know call me method is in savings account, then this will allow. Otherwise, it's not possible. So let me take it back to savings account and let's see. Want to try now? That's now all packages. Go. Either way, if you want to use something, you can use it if you like to use Eclipse to run. You can as well do that. So now in the, let's say Java Java, I'm compiling. Let me see where I have the method deposit. Now current line 19. Line 19, we have the deposits. Okay. Row missing D, line 24, current account. Current account is row D. It's missing. Okay, fine. Can you see that? Cannot find symbol call me. Call me, even though we have call me method here, but it's saying cannot find symbol. Why? Because we are using an object of the superclass to call. We're using an object of the superclass to call this method. So if we're using an object of this class to call this method, is it possible? We have to change it to the method. So we have to change it to a type of the savings account, which in this case, we are changing from the superclass type to a subclass type. It's called downcasting. Downcasting. So if I'm now going to change, I can now change from that by saying savings account. Let's see, SA. Then I will now have, so this is how to change savings account. Then AC3. Remember, this AC3 now is an object of that is of type savings account. So I'm now changing this AC3 to savings account. And when I change, I assign it to a savings account and I call it SE. So I'm renaming it. So I can now call this SE. I know I'm dealing with savings account. I have changed from bank account type to savings account. Doing this, by writing this, you are changing this AC3 to be of type savings account automatically. So whatever this object, we are just renaming the object to change it to SE, so that we can now assign it to the savings account. And then use the SA to call the method. So this will be allowed. And therefore, when we call the method, we're not going to have that issue of saying cannot find symbol. So you see, compilation successful. And then we can now call the driver class. Run, we see checking method call. See, it has called the method. Then the next is just to check the functionality of the program, saying, okay, what do I want to do? I want to check my balance. I select one. Now the next, maybe I want to withdraw. Then I select two. It says enter the amount I want to withdraw. Then 20,000 or 2,000, like that. Then again, it displays all the details. And then again, asks me whether I want to do something. I say 3. say enter the amount to deposit because 3 is for depositing. I will continue until I press 0. Okay, well, let me do this first. Enter the amount to deposit, let's say 4,000. Okay, so now it has added into my account and it displays all the details of my balance here because I have deposited with my interest rate. So if I want to exit, then I press 0 and that's all. That's program terminate. This is just the way we've seen it in our ATM machine, where we'll be prompted with some options to select, which is what I have shared with you. Now, at least we have seen this downcasting. Now, what about upcasting? Changing from a type of subclass to a type of a superclass is only if we want to change that type. So if suppose this is savings account, for instance, if this is savings account, and we want to change these savings accounts to view of type superclass, so we can just come here, change this to bank accounts, just as we did for the other one. Bank accounts, then this AC3 will now be bank account type, and then you have to come here, call it bank account. So this SA will now be, but however, you're going to have an issue when you call the call me, because call me method is not in the bank account class, because we have already changed this AC3 to a bank account, and doing that will lead to an error. Okay, so I think we can proceed with this. Demonstrated with a very good example. So this is the one I've just shown. And as well, we can also use an object, because an object is the ultimate superclass of all classes. So we can use it. Since objects, I can see a faculty is an object, of course, and a faculty is an object. As you can see here, even in this, I can even make this one to say savings account. I can use an object here. So if an object here is a superclass of savings account, because of course it's not a superclass of savings account, but by virtue, savings account is subclass of bank account, and bank account is subclass of object. Therefore, savings account is an object by transitivity. So if that's the case, if I'm using a superclass type, then of course I will need to change it from this type to this type. So I can use an object as well. So this kind of assignment, when we have it as employee, yeah, him is an employee, it's of-type employee, and we now come here and assign a faculty member. So when we assign a faculty member, and remember a faculty is a subclass of which is okay. But coming here now, we change this to view of type objects. So this assignment is called upcasting because we are going off the inheritance tree. Why? Because we are going from a faculty to an employee off to objects. This is called upcasting. So later we see more of this upcasting and why do we need to do upcasting. The advantage of upcasting is that some method applies to superclass and all its subclasses. Yes, superclass and all its subclasses. Such method can be designed to accept a superclass reference so that it can be called with a superclass object or subclass object. So we can use a superclass object or subclass, just the one I've demonstrated now. So for example, methods that will generate a payslip for all employees may have the following thing. Say, okay, we want to generate a payslip, and here we pass an object of this employee to call. So when we pass an object of employee to call, can we pass an object of a staff? Yes, and a staff is an employee. So all this I think I've demonstrated in my example here. This example. So where I need to pass, where I am expecting to pass an employee, I can pass a staff because I know a staff is an employee. So if I'm expecting to pass in here, I can pass ST1 because ST1 is a staff and a staff is an employee. So in this method, if I want to generate a pay slip for an employee, I can pass a staff because I know a staff is an employee. I can pass a faculty because I know a faculty is an employee. But I cannot pass a student. I cannot pass a graduate student because a graduate student is not an employee. A student is not an employee. Therefore, I cannot do that. Right. So later we're going to see more on this. So exercises. So today's class, I think we start the main one called abstract classes, which is supposed to be the real today's class, all the one we discuss now. Just a recap of what we did last week. All right. Now, in abstract class or in inheritance class, remember that when we open this, let me open the bank account class. In the bank account class, we have method deposits, we have method override, sorry, withdraw method, we have transfer method. And we create a subclass of this bank account called savings account. And savings account is now overriding the method of the superclass, deposit and withdraw methods. These are overriding methods. Remember, this is why I even annotated them here with override. So what we're saying here, the subclass savings account has an option to either override the method of the superclass or not. To override of the method of the superclass or not. This is option. It's not a compulsory that a savings account must override the method of the superclass. It has an option to override. It's just like now, remember where I said, if it's not a mandatory that I have to override the method of my parents. When my parents eat, then I have to override the method, meaning I have to define the way I want to eat. I can use the same method. I don't have to define the way I want to eat. It's an option. But there is a situation whereby my parent will force me to override the method, meaning that will force me to define the way I want to eat. I cannot use the way my parent eats. I have to define the way I have to eat. So that is how will my parent force me to override the method, meaning to define the way I want to eat. The same thing, we have a withdraw method, we have a deposit method. And the deposit methods in the subclass is not a compulsory that the savings account must override the method of the superclass. That is to see if at all the method of the superclass can be used without any modification. We know that there is no need of overriding. But if in the case whereby the two different methods may mean different things, cannot be used to serve the savings account. That is the deposit and withdraw method of the superclass cannot be used in the savings account at all. That needs to be modified. The deposit method needs to be modified. So if it is required to be modified, how can we force the child class to override the method to define the way the method is supposed to be implemented? Let me give an example of, let's say, an employee who is to be paid salary. And we have a pay method. The pay method is to pay salary for an employee. And we have different categories of. We have monthly employee, we have hourly employee, we have commission employee. For monthly employee, we pay salary at the end of the month. So whatever the pay rates, if we are to pay you 500,000, we just return 500,000 as your pay. But hourly employee will depend on the number of hours the person worked. In that case, we need to calculate the number of hours times the amount per hour. So if you now determine the amount per hour, multiplied by the number of hours you have worked, that will be your pay. The commission employee will depend on your commission. Probably we can say based on sales. When you make a sale of certain something, you have 5% of the sales of whatever sales of the profits. So we have to also compute that. So the salary, the pay method cannot be used to serve all the three categories of because we cannot use the same method to pay them salary. In that case, the method pay in the employee class cannot be used to pay all salaries of the employee. So that will necessitate for every subclass to define the way the method is supposed to be implemented. Another example is when we look at a shape, we know we have area of a rectangle, area of triangle. So if you have area in the shape, that area cannot be used for area of triangle, area of rectangle, area of square, because each of these shapes has its own area specifically to that. That we cannot use one single method to say area of triangle is the same as area of circle. So how we would now force that child class to override the method by defining the way the area is supposed to be completed. Because by the time we are in that subclass, we know we are dealing with rectangle, or we are dealing with circle, or we are dealing with triangle. So in that case, we know what is the formula for computing the area of that object class. So the same thing here, the deposit method. If deposit method of the bank account cannot be used for savings account, simply because there is interest rates that's supposed to be computed. But then we must have a deposit method that will be implemented in the subclass. In that case, the superclass needs to make that method incomplete, to make it abstract. So when you make it abstract, means the method is not even complete. You only have a definition method header without telling how the method is supposed to be implemented. So this is what we call overriding, when we want to force a child class to override the method. So this is why we said a programmer means subclass here. A subclass normally has option of whether to override the method of the superclass or not. It's an option to override the method or not, as you have seen. If it is composite that any class must override the method, then we must have override the method's transfer. And you can see we have a transfer method here, but it is not overriding here. There's no any transfer method in the savings account. Therefore, it's not compulsory that a subclass must override the method of the superclass. It's not compulsory. It's an option. So if it is an option, how in such kind of situation where the superclass would like to force the subclass to override a certain method? Must not be all. Certain methods, particularly like withdraw, transfer, and deposit. To stream method, that one is okay. We must not make it to be abstract. But withdraw methods is compulsory. Any child class needs to define the way the withdraw method is supposed to be. Probably there are some setting charges or some other things that need to be associated. All can be done. So this is usually the case if there is a suitable default, if there is not any suitable default implementation, meaning that we don't know how the method is supposed to be implemented. Like we said, area of shape. Need to know what shape are we talking about. Like employee here, we have hourly employee, we have monthly employee, we have commission employee, and we have to pay them salary. So this is an example. This is an example here. We have employee as a class. We have the two instance variable, name and pay rates, and we have the constructor here that will initialize the name and pay rate of the employee. So we have the method here, pay, with this now. This is the pay rate to return the pay rate of whatever. So if it is 100,000, we return 100,000 as the pay. Now, this is set pay rate. Of course, it's a setter method to change because pay rate here is private, as you can see here. So let me just go and demonstrate this private of the thing so that you understand why we need to make things private. Now, if I have this AC name, let's say I want to access this name from here, and I'll say AC1, let me write this system dot out dot print line. Let's say AC1 dot name. I want to print the name of AC1. So I say AC1 dot name. Let's see whether name will be allowed to access. Remember, this is a driver class. which is not in the same class as bank account, and name is defined in the bank account. And we say name is private, meaning it cannot be accessed outside this class, outside this bank account. Now we are crossing to another class. Is it possible to access name? Therefore, this should be denied. So let's test that. So you see, a name has private access in bank account, therefore cannot be used to reference that variable. But if I go back to make this bank in the bank account, to make this public, then there will be no restriction. This public means can be accessed from anywhere. Therefore, if I come back to this, compile, then it's fine. The program runs and I will see the name. Once I run, I will see the name, Aisha, because I'm using the SC1 and SC1 corresponds to Aisha based on this. Likewise, I can make it protected. Protected also works. So to what level is different from the protected, between the protected and that? So when we go to packages, we explain from that. Okay, see, it works with that. Okay, so let me take it back to private, but the best is to make it private. Makes it more skilled. So I think you have to understand why we need this setter method in order to be able to modify this, because this is public. Now to string method to return the name and the period concatenated together. All right, so still on motivation, why do we need to have abstract class? So here now we have hourly employee, extend employee. Here is a super class. Here now we are creating a subclass employee, extend this. And we have, because in the hourly employee depends on the number of hours. This is why we have hours as an additional instance variable, different from that of the employee, because as far as the employee is concerned, we don't know whether it's hourly employee or something. So we don't need to have our number of hours worked, because this number of hours worked is not applicable to other types of employee, only for hourly employee. So here we have the constructor. We set the hour to 0. As we come here, we say add hours, meaning that if you work for 1 hour, add 2 hours, 3, 5, like that, we add and accumulate. As we come here, we multiply. We say super.pay times hours. Super.pay, meaning we are calling pay method of the super class. That's why we have the super here, times the number of hours worked. So the concern, what is the problem with this? Here we say the pay rate field represents the hourly pay for the. Here, the pay method multiplies this value with hours work and returns the result. Simple. Clearly, if the pay method is not overriding, that is, if there is no overriding here, if we don't have super.pay here, by mistake, the pay of the hourly employee will be computed wrongly. Because if there is no overriding method, as in like we don't have this pay method here, don't have it here, it means we go to make use of this pay to pay hourly employee, which only returns the pay rate without multiplying by the number of hours. So that computation will be wrong, because the expectation is whatever the pay rate per hour multiplied by the number of hours. And if you mistakenly just make use of this pay method to pay hourly employee, then we will not get the correct pay of the hourly employee. That is, if we mistakenly not overriding this method. So here now we are overriding. So how do we force these hourly employees to override this? Because right now it's optional. It's optional for the hourly employee to override this method. But how can we force the hourly employees to override the method? So this is why we now say, okay, let's make it abstract, make it incomplete. So to force the subclass to override this method, the method should be declared as abstract. Abstract means incomplete. So how do we declare an abstract? We call it abstract methods. Consists of only method heading, like this one now, public abstract double pay. without implementation. We don't have the implementation. We just put this parenthesis and put what? Semicolon. There is no implementation. How the pay is supposed to be computed, we don't know. We only know that every employee needs to be paid salary. The pay method is to pay salary of every employee. But since we don't know who or which category of employee, we allow that to be determined by the time we go to that subclass specifically. If it is hourly employee, we know how to compute. If it is our monthly employee, we know how to compute. If it is commission employee, we know how to compute the pay. So this is why we make it abstract. And if we make any method to be abstract, by doing this, we are making this to be abstract now. If pay is abstract, then the class also needs to be declared as abstract. So meaning that in any class, if there is any single method that is abstract, the class must be abstract. But the reverse is not the case. It's possible that a class can be abstract, but without an abstract method. But if there is any abstract method in any class, then the class needs to be abstract with the keyword abstract. Okay. So I think this is what I've just explained. Once a class has at least one abstract method, then the class is set to be abstract and it must be declared as such in its heading. As long as you have one method that is abstract, then the class needs to be an abstract and must be declared as such in its heading. Like here now, we have it here because we have one method that is abstract. But it's possible that we may have an abstract keyword here without an abstract method. So an abstract class essentially means a class that is not completely defined. Why? Because there is a pay method that is not completely defined. So it's incomplete. So when we have an incomplete method, the class also is incomplete. So the concrete class is sometimes used to describe a class that is not abstract. Like in the case of the one we did, all the classes we have created here, we call them concrete classes. This savings account is a concrete class, driver class is a concrete class, this is a concrete class, this is a concrete class, because they are not abstract. So any class that is not abstract is called concrete. So we use this interchange to differentiate between a class that is abstract and the class that is not abstract. So a class that is not abstract is called concrete class. Now, again, the point I've mentioned that it is not necessary for an abstract class to have an abstract method. It's possible that a class can be abstract, but without an abstract method. So even if all methods in a class are implemented, the class will still be abstract if it is declared as such in its heading. The fact that we said if a class is abstract, we must not have an abstract method. Again, as long as we have that heading in the class to be an abstract, therefore the class forever remains as abstract, as long as the abstract keyword is there. So another one is abstract class cannot be instantiated. We cannot use to create an object of any abstract class. Like for instance, here now we said employee. Here we said employee. An employee here is a class. We cannot create an object of an employee class. Yes, because remember what we said, a class is not completely defined. We expect a subclass to complete the class. So by then we know if it is monthly employee, we know who is this person. But when we say employee, we don't know. Is it commission? Is it hourly? Is it monthly? We don't know. So employee, we don't know who is employee. That is why it is abstract. And the pay method, how can we determine the pay if we don't know the type of employee? So this is why we said we cannot use to create an object of that class. However, if we have the monthly employee, we can make something like this, which I think I have demonstrated that. I can use this to say monthly employee here. If monthly employee is a subclass. So I can now write something like this. Obviously, I know monthly employee is an employee, so I can write this. But one thing I cannot do is to write this to say employee n equals to new employee. I cannot do this. because employee is abstract. I cannot instantiate this. This new employee is called instantiation. I cannot write this. But I can have monthly employee. Because I know monthly employees are employee. So I can do this. I hope I'm communicating, guys.
Yes, sir.
Okay.
Hello, sir. Listen, I have a question.
Yes, please go ahead.
This particular code we are running now, I noticed that we have two this variable, private string name, private double period, but there was
Yes.
no getter set for it. They didn't set any getter on the code here.
Yes, getter method is an optional. It's not something mandatory unless you need it. Remember that this is why we have the dot here. It's not a complete program. We are just writing some parts of it in order to demonstrate. The main focus here is to understand what is abstract method and what is an abstract class. So if we understand it's not a complete program, this is why we have the dot here. So you can have as many as possible. You can have to string method, you can have getters, you can have setters. So the focus is not to discuss about getters or setters, but to discuss about abstract method and abstract class. That's why the focus is on this now. The focus is on this abstract method. Therefore, having this abstract method will lead us to have an abstract class. But other things, remaining things can all be added here. You can add as many as possible. You can have getters, setters, all that. You can have them. Is that okay? Hello?
Yes, sir. Very okay. Thank you, sir.
Okay. Thank you. So you can have the getters and setters for all the instance variables. You can have them, but the focus is not on getters and setters, but rather on the method here. Having getters and setters is not something to say an abstract method. It's the pay that can give us issue, because we cannot use the pay methods to pay all employees. We need to know whether monthly employee, hourly employee, or commission employee. But then we know how to compute the pay. But in the employee class, we don't know. We cannot use the same pay here to pay all employees. So this is what we are saying that, okay, how can we now force those subclasses, any category that is going to be a category, that is going to be a subcategory of employee, must have a method pay implemented, because that subclass must know how to compute the computation, so how to determine the pay of the employee. But as it is here in the super class, we don't know how to compute. Cannot use one single method to pay all employees. Yes. It's just like we have here now. We have a class. Let's say we have a public class shape. So I now come here and say, okay, in the shape, I want to come here and say public, let's say double area. So now I want to compute area. Area of what? What is shape? Area of what? A shape is abstract. Even from the word, we know shape is abstract. We need to know what type of shape. Is it area of circle? Is it area of triangle? So if now I use area of circle, for instance, let's say, for instance, math.pi times radius times radius. Can I use this method for the area of rectangle? Here now I'm putting the formula specifically for area for circle, pi r square. And I cannot use this method for rectangle. I cannot use this method for triangle. I cannot use this method for other shapes. This is specifically for circle. Therefore, if I have the method area here, will not make sense. Will not make sense, because I cannot use this area across all. But I know if I have anything that is going to be a shape, must have an area. Therefore, I need to just make it to be abstract, so that any shape needs to implement how the method area works by doing this. So I now add abstract keyword. Remember, once we have an abstract keyword here, any class that has an abstract method must have an abstract. The class must be abstract. So I need to have an abstract also. So a public abstract class shape. So I know shape as it is here is saying any class is going to be a shape must have an area. Simple. So now I can say perimeter as well. Any class that is going to be a subclass of shape must have a perimeter. So if I now, let's say for instance, I need to have a public shape to have a constructor. Yeah. But all I need to have a constructor, let me say private name of the shape. So let me say here now, I will have public string to string. Public string to string. Then I will now have string, let's say area or name. First the name of the shell. Let's say get plus get name. So I don't need this name here. I don't need the constructor here. On its so this will get me the name, get class or get name will give me the name of the class. That is to give me the name of the shell specifically. Then concatenate. Let me have a new line here. Then let me say area. Then I will give a space. I will concatenate with area methods. Then I will have a new line here. Then go here and say I need to have perimeter. Then I will have perimeter methods here. Okay, fine. So you see, I have perimeter here, I have area here. So as it is here now, I know this is an abstract, this is an abstract, it is not defined, it is not set to be. I don't know how the computation of perimeter, I don't know the computation of area, I don't know the shape. I only say subclass of shape. So here now I'm defining it in a class. Any class want to be a subclass of this shape must implement the area and perimeter. This is forcing the subclass to override the area and perimeter now. Because by then, if I say area of circle, if I say a circle is a subclass of shape, because a circle is a shape, that is fine. So I know the formula for computing the area of circle. That I will now compute happily. So let me just save this, or let me create another class. Yeah. So let me say public class circle. So a circle is a shape. So I can say extend shape, meaning it's an extension, it's a subclass of shape. It's a subclass of shape. So now I'm dealing with circle. If I'm dealing with circle, I can now define the dimension of circle. I know in the circle I need to have radius. So I will now say int radius. Then I can have my constructor so that I can construct to say this is a circle by giving a default value radius. Because I want to draw a circle, I need to know the radius of the circle. So later I can call it data method to change if I want to increase the dimension of the circle by changing the radius. So I can have that. So public circle, this is a constructor. Then I can now have the radius as the parameter circle. So I can have int radius. So I can just come here, initialize this dot radius equals to radius. Okay. Now, next, if I have this cycle, the radius, initialize this, fine. Next one, I can now have the implementation of the method. So I can now have public double. Remember, what we have in this class, now shape class, we have area method of type, the return type is double and it's public. It's abstract here. Abstract means incomplete. Having one method incomplete or two methods incomplete, the class is incomplete. That is why we have to make it abstract, even the class. So here we are now dealing with concrete class. A cycle is a concrete class here. It's a concrete class. So public double area. So now I'm overriding the method. So if I like, I can annotate it here by putting this override. So I can now have the radius. So in this case, I can happily return to say maths.pi means 3.142, as you know, times the radius here, times the radius. So simply I'm computing the area of the circle. At this point, I can happily write this area of circle implemented in the circle. I know I'm dealing with circle. But in this case, where I'm dealing with shape, how can I write that formula of circle here? Does that mean the formula of circle is the same as the area of circle is the same as area of other shapes? What if I want to deal with rectangle? What if I want to deal with triangle? What if I want to deal with rhombus or any shape? Specifically when I go to that subclass, I know how to compute the area. This is why this one is saying, okay, let's just make it a way that every class must have method, area, and perimeter. It's a must. Unless if it's not a must that I have to override those two methods, then the class cycle here needs to be an abstract. As it is here, it's implemented only one class, only one method, area. But the remaining method, which is cycle perimeter, is not implemented. Therefore, if it is not implemented, the cycle needs to be an abstract because it has not completed the shape class until when those two abstract methods are being implemented. But if it is only one implemented, then the cycle also needs to be an abstract. So in that case, let's implement the method so that it can stand as the concrete class. So here now, perimeter. So perimeter of circle, I think, is 2 pi r. 2 pi r. Now I can have two string methods that will now return. Remember, the string method here in this superclass is returning the name of the circle, the area, and perimeter. So, but I need to know the radius at this point. So I can concatenate with radius here. Public string. So now I'm overriding the method of the superclass. I can also write this override here. So I can have return super dot string. Then super dot string, so I can now have the radius here. So this will concatenate with the radius when I'm dealing with circle. So I don't have to repeat saying name something, because if I want to get the name or get those dimension or other things from the other class, I cannot get them. But I can call the area and all that. So here now we have this. Next, suppose I want to create a circle. Sorry, a rectangle. Let's say public class rectangle. A rectangle also is a shape, so extend shape. So if it extends shape, what are the dimensions of rectangle? Rectangle has what? let's say int, let's make them all ints, private int, length, comma width. So we can now have the constructor. As usual, please don't forget that you can have as many. Let's say if you want to change the radius of the circle, so you can have the methods here, data method. Let's say public void set radius. You can say set radius or scale radius or the size cycle. Like must not be set. You can call it resize. I can say resize, and then resize with what? New radius R. Then just pass this and just come here and say radius. So, but if you want to say the size should have whatever the radius plus this. So you are now adding. So the radius will be radius plus R. Whether you pass a negative, it will be minus. So you can scale it up or down. Yeah. So I just say resize. Then the same as set radius, like same as set radius. Just that's it. Data method, just a name. Okay, so let me just finish, then I can now come back to save this. So in the case where I want to change the radius, this is for the hands operator. I believe you know this. The same as radius plus R. So when you pass negative, it will negate this. It will become minus. So it will now reduce that and store that as the new radius. Now, for this length and width, we can now have the constructor public rectangle. So we can have length in width. Hello guys, am I communicating? I hope I'm not teaching myself.
We are with you, sir.
Okay, so if there is anything you don't understand, please feel free, ask. This dot width equals to width. Okay, so these are the dimensions. For rectangle, we need to know the length and the width of, or length and breadth, depends on how that will. So this is the constructor. So we can now have the override method. Let's have the annotator here. Say override. It's not a compositor. We must have this annotator. Public double. Remember, the return type must also be double. If what you have in the super class is double, you have it in the concrete abstract class is double. Therefore, in the concrete class, it is also double. And the spelling must be correct. This because it's an overriding method. So now you see this area. This is one of the reasons why we need to have this. The way it is implemented here, area in this recycle, is different from that of the rectangle, because area of rectangle is different from the area of circle. So because now we know we are dealing with rectangle, so we can specifically write the formula for rectangle. So imagine we just put the radius, we put the area here, we computed the area here, and we use the formula of rectangle. Does that mean the formula of rectangle is the same as the formula for the circle? It's not. But all we are saying here at this point that anything that is going to be a shape, or that is going to be a subclass of shape, must implement the method area and perimeter. That is just what we are saying here, nothing more. So here now the area will now be length times the width. All right, so the perimeter
Hello, sir.
Yes.
I think to be on the safer side, can we use double for the length and width? So
Why
to
not? You
pick
can.
up the decimal.
You can use
So
it.
thank you.
You can use it. If you know the length and the width can be negative, that's what it can be decimal points, you can make it double. Yes. But however, when you compute length and length here, when you multiply integer times integer will give us integer, and the result will be returned as double, because the return type of this is double. So let's say 5 times 6, for instance. So if you say 5 times 6, making 30, the answer will be 30.0. So you can make it that double right from the beginning. So here now we can have public to string. So we can now have dot to string /n. So we can display the dimension here, length. Okay, so we have this. Now, next one, I may have another one, but this one now I can say public plus square now. A square is a subclass extend a rectangle rather than, because from rectangle I can get a square when all the four sides are equal. So I can now have, for this one, I can just say length, no more, because the length and the width are the same in the case of this. So I can now have public square, public square is length. So in this case, I need to refer to the constructor of the superclass, because I don't allow the compiler to insert the defaults to that. So I can pass as this length and the width the same length. So when I say super, what am I calling? I'm calling the superclass of square, and superclass of square is called rectangle. And in the rectangle, we have a constructor with two parameters, length and the width. So I'm passing the same value as the length, the same value as the width, so that it becomes a square. See how the inheritance is, to give us a flexibility, because from square, once the four sides are equal, then I will have my, if I'm dealing with rectangle, once the four sides of the rectangle are equal, then it becomes a square. So I can use everything I have in the square. So I don't need even to compute the area and the perimeter, because it is the same thing. I can use the one for the superclass. So that's all for this one. I don't even need to have the string method, because I can still make use of the one for the superclass. So this is one good thing. We'll make it short because we can inherit. Yes. So the next I will do now is to create, let me create a test class. So let me say public class, let me say driver class or test class, whatever you want to call it. So public static void main tags Okay, so here now, I can create some instances of those classes. So here I can say a rectangle is a shape, so I can make it a shape. I can have an array of shapes, yeah? Yes, I can have an array of shapes. Let's say no array, right? So I don't need to show you this. Array of shapes here, equals to new. Then I can have, or I can create something like this. So I can have any number of shapes. I can say new cycle. I can create one instance of cycle. I can pass the radius 5. This is the initial radius of the cycle. I'm creating an array, so I can pass as many as possible. I can create for the rectangle. The rectangle has 2 dimensions. Remember, the length, which is 10, and the width is, let's say, 6, whatever. I can create another instances of square or a circle. I can create as many because I'm creating an array. So I can just pass one dimension here. Let's say it's X. Then I can add another circle in any order. Okay, sorry, I need to put a new operator here. Then circle, the radius of the circle is this. Then I can have, let's say, another square. Another square. Square as, let me say, this one, well, let me create a rectangle. A rectangle here. The rectangle, let me say, is having 12 by 2. Okay, so now this is an array of shapes I'm creating. I'm putting everything in an array. Optionally, you like, you can make it like this. You can say shape, let's say cycle 1 equals to new cycle. Then you can pass the number 5. This is one way. Then again, shape, the same thing. I'm just making it an array here. So I can, this is shape here for this. I'm using this for this. Then this one for rectangle. I can have it like this. Again, because a rectangle is a shape, remember I've demonstrated that I can call it C2. That way, just a name. If you like, call it R1. So like that, you can do for the circle like this. Like you want to write it this way, or you want to make it an array, you can write this. So now next, if I like, I can use for loop or enhance for loop to iterate over to display all using the string method to display, to see the area, perimeter, and circle, and the dimension, everything. I will see them in one view straight away. So I can use what you call enhanced for loop. I can say shape S as shapes. Then I will now write system dot out dot print line. Then I will say S dot, or just print S, or S dot to string. I think I've taught you how to use implicit or explicit call. As far as this is concerned, S is an object. I can print it. Once I print this, it returns to string method. And that string method will return the value done by that method. Okay, so let me go and start saving this. I will save this. Let me create a folder here. I will call it shape. So I will save this with the name shape.java. Then I will save this with cycle.
Good evening, sir.
Yes.
Yes, sir.
Yes, go ahead. Ask your question, please. Yes, I'm with you. Ask your question.
Okay. Okay. My question is, please, can you shed more light on the enhanced for loop, the one you used just now?
Okay. Okay, let me explain now. Driver class.java. Okay. Enhanced for loop works like this. It's shorter, easier. What it does is, there's in other languages they call it for each. Like in PHP, in some other languages called for each shapes as shape. So meaning I'm picking each of these. That is, I will take this, the first iteration will take new cycle 5, though just the way it is here. So each of these will now be taken and assigned to be of type S. And that S is of type shape. So it meaning that each of these has this. So when I take the first iteration to take this, because this is an array, this shape is an array. It's an array. So when we have this, to take it as a type shape and assign to S. When we assign to S, we now print the S, which now calls to string method of the class, which is cycle in this case. Now the next iteration will be rectangle, and rectangle, because remember that I said this shape is this. So each of these, 1, 2, 3, up to this number, each of these in the iteration will now pick the first one assigned to this S of type shape, and next one will take and assign to S as this, which is similar to the for loop that we have for int I start from 0 to I less than shapes dot length, then I plus plus. It's the same thing. So in the next iteration, you will set what? System.out.print line like this. Now say shapes I. So shapes I, when I is 0, remember that this is going to start from 0. When I is 0, it's going to say shape 0. Shape 0 is what? Is this. This is shape 0. Because we say for I start from 0 to I shape dot length. Length means 1, 2, 3, 4, 5, 6. Less than 6 is 5. So it's to stop at 5, obviously, inclusive. Then I plus plus, meaning that you move to the next one, move to the next one, move to the next one, move to the next one. So instead of you writing all of this, you just write this for, and this same iteration is the same translated to this. So because this is an array already, it's an array as you have defined here. So each of these will take and assign to this. Next one will take and assign to this. Next one will take and assign to this. So this is what you call enhanced for loop, which works the same way. If you like, you write this line or you write this line, all the same. Is that okay? Is that clear now?
Yes, sir. It's okay.
Okay.
Yes, sir. So, sir, a follow-up question. This S assigned, it doesn't matter. It can be anything. It's just the name, but
Yes. This, if you like, you can call it shape.
okay.
Like It's just anything you like. This is a type because a shape here is an object. What we have here meaning is an object of which type? A shape class, because this comprises all. Circle is a shape, rectangle is a shape, square is a shape, this is a shape, this is a shape, this is a shape. That is why we give a shape here. But this can be anything meaningful. Like call it R, call it S, call it whatever. Isn't it? As long as it's a valid identifier, that's all. So when we
Okay,
go
thank you, sir.
back to this, yes. So we go back to this, we say Java, start.java. Let's compile one by one so that since we have not compiled each of them, so if there is any error, we will be able to fix or move on. Okay, now first one, no error. Circle, shape runs fine. Next one, let's do circle. Okay, circle, no error. Next one, rectangle. Okay, rectangle has an error. It says what? Java. Okay, sorry, it's not an error, but say I have to put Java. Okay, that also has no error. Then square. Okay, so now square has an error. Let's clear the screen and then fix it. Okay, it says length is private, expected. Okay, so the type is missing. So we come here, yes. Type is missing here. Right, so invalid method declaration, public square. So we check if the spelling correct for it. Okay, see the spelling is not correct. Square is the name of the class that is mistakenly spelled wrongly. So this square needs to be corrected. I think we have it here corrected. Okay, so I have to go and rename my class. Remember, the name of the class must always be the same as the name of the file. So in the square here, I have to correct it. Okay, so now if I go back, let me open this so that in case you want to modify. So square. All right, so here now, square, okay, square, okay. Square, no error. Okay, next, the last one is Java driver, Java. This one has issue. Expected something. Okay, I put semicolon. Why it's not, there's not supposed to be a semicolon there. Share. Java driver. Cell line 5. Line 5. Then we go to tools, customize toolbar, toggle line numbers.
The rectangle, the line with the new rectangle, that's the semicolon.
Okay, thank you. It's just comma that is supposed to be. Only the last one we will not have. All right, so here now, okay, compile successfully. Now next is to run. Just say this driver here. Right, so we have, let's have a new line after printing each of this. Let's have a new line. When we compile all Java star.java. Okay. So you see, one click, you have a name cycle, because the first one is cycle, using that get class of get name. Area is this, perimeter is this, radius is this, name, radius, a cycle is this. Sub area is this, perimeter like that. So what if we want to call the size? This is where now do. So remember we have a resize method. Do we have the size method in the? We have the size method in the. Where is it? In the cycle
In the
class.
circle. In the
Thank you.
circle.
Yes, in the cycle class we have resize, meaning we want to add something to it. But then when we come to the loop, we don't know whether we are in radius or we are, because by the time I come here and I say share dot resize, I'm going to have an error when it comes to rectangle, because the rectangle has no cycle. And in fact, since I'm using a type shape, meaning automatically it will try to look for the size in the shape class, while there is no method in the size in that class, and the subclass cannot. Yeah, of course, sorry, yeah, it will work for this. Does the method? No, cannot. I have to downcast. I have to downcast because a superclass cannot inherit a child class. So let's say I want to resize this. So now the issue here is, I'm here in the loop. If I call resize, the resize is only available in the cycle class. What if we are in the rectangle iteration? We're going to have an issue because there is no resize in that class. And another thing is this, I'm using a type shape to represent all of this. And cycle cannot, a shape cannot inherit cycle. So I cannot use an object of type shape to call any of these, to call method from this class. To call method of this class. There's no way. Yes. So now let's see whether we're going to have an error. Of course, error must occur, cannot find symbol besides. Cannot find symbol besides. Why? Variable of type shape. Method. Yes. So it's of type shape. So even if this, we check for an instance of cycle, let's say we have something, we have a check. We said if shape instance of is it like that? Like this. Instance. Yes. If it is an instance of cycle, meaning it's an object of cycle, so that to avoid anything that will now apply to any wrong class. So if it is a rectangle, if it is a square, it will not apply the size. Yet, the type is of type shape. This will also lead to an error because we cannot call the size method using the shape type. So we need to downcast it to be of type cycle if truly we want to call the size. But if method resize is in the superclass shape, then no problem. We can use an object of type cycle or an object of type shape to call the method because of inheritance is from bottom to top, not from top to bottom. Parent cannot inherit child. Only child inherit parent. So I'm giving you the general idea here. If you understand this, then I don't think we're going to have any issue with inheritance. So you see, despite the fact that I'm only checking for cycle, but I'm still getting trouble saying cannot find symbol size. So what do? We downcast. So I'm now going to wrap this. It's only going to apply to circle. So I will now come here and I will make it ready. I will make it circle. So I will make it like say S equals to, then I will now have the circle. Remember how to change. Then I will change the shape. So I'm now changing this shape. If shape is an instance of circle, means an object of circle. So when it comes to rectangle, it will skip this. When it comes to this, it will skip. Only going to apply this and this. That is it. So when it comes here, I say I'm adding 10. So if I'm adding 10, how much circle will be? The circle will be 15. How much circle will be here? 13. Sorry, 18. Isn't it? Yes. So now I can say S. Let me change it to C. C dot resize. So I'm now changing C dot resize. Then it will now resize that. So it's only going to call the size if I'm dealing with what cycle. And let's see whether the radius will, when we display, let's see whether the radius will be 5 or 8. Of course, it will not be, because 10 will be added to this, as we said, scale up or size. So this should not give us any trouble, no any error. Yes, so no error. Java, driver. All right, so no trouble. Cycle, can you see the radius? What we said about the initial 5, what we said is size. We now resize it to what? By adding 10. So meaning add scale up to 10, making 15. The next cycle is 8. Scale up to 10, add 10 to it, becomes what? 18. So this is a circle. See? For a rectangle, we will not see because there is no radius in rectangle, only length and the width. We have the area and perimeter. Plus, question?
Lisa,
Yes.
this instance of keyword, what does it do? Is it a
Instance
reserved
of
keyword for
keyword is
Java?
checking. It's checking whether the object is an object of a particular class. So if now, remember here we have an array and we don't know in the iteration, whether in the first iteration, second iteration, third iteration that is a circle, we are checking whether the object in the iteration is an object of cycle. So this is what we are now using. The instance of is checking if the shape, that is this shape, is an instance of cycle. See, here now we are checking. Instance of meaning is an object of cycle. So in the first iteration, is it an instance of cycle? Is this an instance of cycle?
Yes, sir.
Fine.
Yes,
so
sir.
this is true. Then it will now downcast and call the size. Move to the second iteration. When we are here, is it an instance of cycle?
No, sir.
No. Next one, is it an instance of cycle? No. Next one, is it an instance of cycle?
No.
Yes. Then it will do this. Next, is it an instance of cycle? No. Is it an instance of cycle? No. Then it will do this. So the same thing, if I will now want to calculate how many cycles do I have? You see, how many cycles do I have? Then I can now say, if it's an instance of cycle, count the number of cycles. Like for instance, I have an array comprised of different types of accounts, savings account, current account, domiciliary account, whatever account, I have them mixed together, but I want to separate all savings account, or I want to count all savings account. I can use instance of method. If account is an instance of savings account, then what do I need to do? Do something. Either call certain method that is applicable to only savings accounts, because the method is not available in all classes. It's only available in savings account. Then I can use the instance of method to make sure that I'm only applying to savings account. So the instance of method will allow us to do that. So we said, and the object, is it an instance of cycle? If yes, then convert that to lower class, because we are using superclass type shape. And we cannot use superclass shape to call the method of the subclass, because there is no inheritance from the top class to the bottom, to the child class, only from child class to the superclass. So if now, for instance, I'm using an object of the superclass. For instance, I have, let's say, cycle here. Let's say cycle C equals to new cycle. Then this is fine. I can happily say C dot resize without needing to do any casting or off casting. I don't need that because I'm specifically applying to this. But here now I'm in iteration and I don't know whether the first one, second one, third one, fifth one, I don't know. I may read it from database and push into an array, which I don't know how the arrangement is going to come. It is you, programmer, who you are now interacting with the code. The user will not see the code. They're only interested in seeing, okay, they'll probably prompt him to select whether he wants to compute cycle, rectangle, and then call the appropriate method as it may be. All right, so any more questions? I think we have gone beyond time, but if there is question, please ask, otherwise we'll stop here. I wanted to finish even abstract classes, but yet we have not to talk of starting interface. But next time we'll do interface and for the modules. Yes. Question? I believe we have exhausted everything about abstract class. Yes, question?
A question for my.
Okay, so in the absence of